All right, guys. So here we are, Earth Moving 101, loading the shovel. I was going to call it loading the bucket for a while. Originally, I was going to start with how to dig a ditch, and then I thought, you know what? No, we got to boil this right down here. We got to boil this right down. And what we got to boil it down to is where we would normally start if the training process for a heavy equipment operator was the way I would like to have it, and that would be on a shovel. And that would be on a shovel for a good 5 years, son. And the reason for that is a few things. One, you learn how the job works. Two, you're the lowest paid guy, so if you make mistakes, you don't get yelled at quite as bad. Three, so that you could learn how to run a shovel. I kid you not. There is an art to running a shovel. And just about every person I've ever trained, and I know it was the way when I was trained, had to get yelled at, beat at, told they were no good, and would never be anything because they couldn't run a shovel. I think the exact words verbatim, "You young fuckers couldn't rake a stick up a dead dog's ass," is what I was once told. And you know what? It was 100% correct. And I relive that memory every time I watch someone else struggling the same way I struggled. And I think perhaps if maybe a different way of explaining it could have helped me, and that's what I'm hoping to do for you. So here we go. So, you're a laborer. Here you are. Mr. Stickman or Stickwoman, you are happy because you work for Graph. So now, Stickman, I ask you, dirt pile, I would like you to move this pile from here to here. Okay? That's where we want to go. Now, how are you going to set yourself up? Are you going to stand here with your shovel and throw it? No, that would be a bad idea. We can all see that right away. All right, so you position yourself properly. And you are extra happy now because you got a gold star. Okay, there's your star. All right, now, if you start moving this pile, are you going to start digging at the bottom of the pile and putting your shovel in and moving it over? Are you going to start up here and get your first shovel full from there and move it over? Well, let's look at the physics. You pick it up from down here, your shovel's down here at elevation 0. You're now going to lift it up, presumably and probably to your waist height to make it comfortable to turn. So you've just moved it up 2 feet. And then you're going to turn, you're going to dump that same material probably up at this height and let it fall to the ground. Or maybe this height. Depends. Depends how quick you are. All right? So now you've now had to use energy in your body, i.e. food, or pop, and you've had to lift that material 2 feet vertically. Whereas if you'd taken a scoop from that same 2-foot elevation and just rotated yourself and dumped it, you have now eliminated 2 feet of vertical movement. That's a double gold star. All right, double gold star. So Stickman is happy. Stickman passed his first test of positioning himself properly and also rotating and using the right heights and restricting movement where movement is not required. And that's generally the whole concept, is don't do more work than you need to. There was an old saying that used to be, well, it's not old, it's still around. Don't move the dirt twice, son. It's like, yeah, thanks, Pops, we got it, okay. But let's maybe dive into it a little bit more, because I'm going to say sometimes there is a reason to move the same dirt twice. They're fewer and further between, and it comes in more advanced knowledge of earth moving and more tricky ways and different methods to get to an outcome, but there still sometimes is a need. And sometimes there's worth in just backfilling a ditch with a stake on it to redig it the next day because you don't have a gaping hole full of water. So it's more work, but it's the right thing to do, and in the long run, it saves you time. And that's generally where we're trying to get. So now let's look at actually loading that shovel from that pile of dirt. Here's a close-up. Here's your dirt pile. Here's your shovel. It's not a great shovel, but it's a shovel. When you take a shovel full, are you going to either A, take that shovel and take an inch off of the entire face until your shovel becomes full, so as you move your shovel up, this material piles up in here, you load your shovel, and then are you going to spin around and dump it? Or it's the same technique starting from a waist comfortable height going up? Or option B, are you going to stab that shovel into the dirt and then take that pile of dirt away. That sounds like a much better idea. Let's explore that a little further. So, here's our dirt pile again. The physics behind that is as you load your shovel, if you were to go with method A, and you're taking that 1 inch off of here, the whole way up, you have this shear action that happens between the material. That's that resistance you feel. Aside from the weight of the material lifting vertically, you actually have a shear there as your shovel shears along the ground. In finer materials, i.e. sand, you don't notice it as much because there's no real resistance. But if you were to dig through a big rock, there's a rock there and all of a sudden you hit that, that's that shear I'm talking about, that momentum just coming to a grinding halt because that rock is lodged in here and you're trying to just take that little piece, and what ends up happening is you end up trying to shear that rock, which obviously usually doesn't happen. Usually the rock rolls out or whatever it might be. But that shear is what I'm trying to eliminate. So if I take my same shovel and I stab it into the dirt and I see my shovel can hold this much volume, so I want to hit the dirt in the right spot and go in and penetrate in and then do a quick lift motion and free that dirt and then get into my moving motion. And so that is loading the shovel. And whether you're running an excavator and you're going to load an excavator bucket, or whether you're running a skid steer and you're loading a skidder bucket, or whether you're running a dozer or a grader, in that situation you're loading the blade, not the shovel, but it's the same concept. You're grading material, you're gathering it, you're scooping it, whatever method it is, and then you're carrying it by some means, whether it be a Rotec bearing that rotates on an excavator, or wheels moving on a loader, or the blade itself physically just carrying it with the dirt, the ground, existing grade holding your material up. You're loading, you're moving, and you're releasing. So that's what I'm going to try and focus the series on. The first one was loading the shovel. All right, everyone, Stickman's had a fantastic day. Not only was he given an opportunity to learn how to run a shovel, which he did quite well at, but he's actually got the opportunity to get on an excavator now, a real big shovel, and do some digging. So I've set up a scenario here. We're just going to assume no utilities in the ground, very straight going. There is a cap layer that needs to be removed and salvaged. Fairly typical of most digs in a construction site. That's sort of your road-weary surface to make it an all-weather site. Any good site at least will have something down. Not so good sites will probably just be a big mud pit. But anyways, we're going to get that off, salvage that, throw it to the side for reuse. Whole another chapter in itself there. So let's just say for now we've moved that material off, we've gotten rid of it. So things have gotten a little simpler here for us. And we're basically left with a strip surface that kind of comes down and looks like that. As crossed through the trench profile, obviously you're not going to strip the whole site. You're just stripping the trench of where you're working, plus some working room on either side. Got that stripped off. He's going to get his hole opened up by putting his teeth in here and starting a bit of a horizontal dig with a curl at the end at the exit to get that material out. He's going to keep going, and then generally he's kind of going to have a bit of grade with an incline starting to head up like this. There's not a lot of other ways to open the hole. I mean, you can go a little bit more haywire and just dump it in and just scoop all the way down. But generally this doesn't take much longer. The key is that the material you are knocking up on top, which you will as you curl out at the end of each stroke, generally as you get the hole open, you'll have a bit of windrow spillover. Just knock that back in and just knife the sides down. I'll show you that in videos later. The key is, once this is down, what I really want to talk about here is how we continue on forward. We go back to that pile with Stickman 1, scenario A, he's lifting up that pile. He's taking that 1 inch or 2 inches of material the whole way up his fill, or his cut, I should say, and taking it one by one by one. And then with each movement back of whatever depth, given the bucket size, he loads that bucket by the top. Every time he's reaching from up here down to here, you're starting to see the issue. Elevation 0, minus 8 feet. He's going to be going up into a truck, I'm going to tell you here. So here's his truck positioned properly over there. Okay, his truck, for the key is plus 8 to get over the sideboard. Look at this vertical movement. That's a lot. But who cares? We got a big excavator with lots of fuel and a big turbo on it. Lots of fun. It's true. It's true. I would say 70% of the people I watch running a machine do not do it the way I'm about to show you. They do this. I don't know. Who cares? It's just fuel. It's true. But when you look at the math, that's a long ways. If I told you this instead, forget about all that nonsense. Instead, enter down your trench. Enter down as far as your bucket needs to be full in a scoop. Bring your teeth in, chunk that out. Chunk that out. Chunk that out. Let's look at the math on that. This first bucket right here, number 1. That there, we had to reach down approximately to an elevation of -2 feet. We then lifted it up to 8 feet. So bucket 1 was 2 plus 8 is going to be 10 feet of vertical movement. Okay, delta V. Then we do number 2. So that one is going to come down to -4 feet. So that's bucket 2. Sorry. This bucket 2. 12 feet. Delta V. And so on. So in this scenario 1 where Dodo Brain was taking his 2 inches, reaching from the bottom and digging up and digging up and digging up and continually swatting at his grade, he's moved himself every time he's had to reach down to the 16 feet or 8 feet below grade and then reach up. Whereas scenario 2, Stickman the smart guy, he chunked it out on his way down. He's only got 1 pass to do down here, and it probably won't be until he moves back and does a bunch more bulking. Just bulk that puppy out. Why not? And then once you get down to your dig height, then all you got to do is reach forward and do 1 trowel pass. So all you got to do is just clean out that floor, and it's nice and quick. This here, I'm going to say 25 to 45% quicker than this method. I'm welcome feedback on that, but I've done a lot of thinking on it, and I got showed by a guy a long time ago. He actually said to me, Trev, why don't you dig the ditch from the back to the front? And I thought, what the hell? That makes no sense. Like, what does that mean from the back to the front? Like, everything would be hooky. And he's like, yeah, you're right, it would be, so it doesn't really work, but if you think of the mechanics behind it, it's pretty beautiful. And I did a lot of thinking on that, and where I see it most applicable, and where I see this done, and then guys out in the patch are going to be like, yeah, we know this, you West Coaster, you've never seen frozen clay like we have. And that'd be true, except for I have, and I hate it, and I'll never go back. But here it is. Ditch, like so. Scenario, we'll go with A. We'll go A the wrong way. Okay, so here we go. Like this. He's digging. Machine's here. He's heading that way. Okay? He's ripping frost. He's going to stick his ripper in, and he's going to rip it all up. Rip it up real good. But what's he doing? He's pulling that ripper into frozen material. Terrible idea. Here's a better plan. Go like this. Where if you want the ditch to go that way, you're going to sit your machine here and say, here you've opened up, but it's just, this is ripped, okay? And over here is unripped. Now he's got a spot to break that material to. So when he penetrates in, he's creating that shear, that breakaway to break that away. It's a similar story as to breaking rock. If you were breaking rock, you would do it this way too. It's these mechanics, guys, and I don't know if hopefully the whiteboard is making sense. I think it's going to be a combination of the whiteboard, and then hopefully you see me do it in the excavator, in the machine, and you're kind of like, oh, hey, I get it now. And that's part of the hardest thing of all this, is how to describe and feel. The ideal thing would be I put you in a machine, and then I just remote into you and move your muscles, and you learn what it feels like and what you're looking for and what you're trying to do. That's not going to happen anytime soon, so this is hopefully going to bridge a bit of the gap in the meantime. So thanks for joining me. It's been fun, and I hope to get feedback. All right, guys, work safe.